Hello. Hello.
Hello, Pritam sir. Hello.
Hello.
Sir, namaskar.
Namaskar. a, a very good evening to our expert, Engineer Pritam Chetan Pothal sir, and also a very good evening to all the participants. I am very much happy to share my views that our participants are continuously participating in this 6 days Atal online faculty development program sponsored by AICT. So I am very much thankful to our participants. So today we have a very nice topic which will be delivered by our expert, Engineer Pritam Chetan Pothal, on the topic application of cementitious composite geosynthetic matrices in canal lining. Before that, being the coordinator, I want to introduce myself. I am Dr. Pankaj Kumar Das, Head of the Department of Civil Engineering, Synergy Institute of Technology, Bhubaneswar, and we are conducting the online Atal FDP on title Revolutionizing Construction with Sustainable Advanced Materials. Engineer Pritam Chetan Pothal did his MTech from IIT Roorkee. Presently, he is serving as Superintending Engineer, Nimapada Irrigation Division under the Water Resources Department, Government of Odisha. He has 17 years of professional experience in the irrigation sector, basically in surface irrigation, piped irrigation, and flood management and embankment protection works in the coastal regions of Odisha. Throughout his service, he has been committed to modernizing irrigation practices through the adoption of advanced technologies, including geosynthetic concrete lining for canals and embankment slopes, as well as underground pipeline irrigation systems aimed at enhancing water use efficiency and sustainability. So, he has vast experience in this particular field. Now, I welcome again our expert, Engineer Pritam Chetan Pothal sir, to address our participants on the topic application of cementitious composite geosynthetic matrices in canal lining. Welcome you, sir, again to this faculty development program, and I request you to start this session, sir.
Thank you very much, sir. Very good evening to all respected professors, faculty members from various engineering colleges across India, and my fellow participants. It's a great pleasure for me to have the opportunity and to present before you some of my work experience at this prestigious technical meet. Already Pankaj Kumar Das, sir, head of the department, has briefed my introduction. So I am Pritam Chetan Pothal, now serving as a superintending engineer in the irrigation department, Nimapada. in government of Odisha. First and foremost, I sincerely convey my heartfelt gratitude to Pankaj sir, Pankaj Kumar Das, Professor and Head of the Department, Synergy Institute of Technology, and Engineer Mausumi Mahapatra, Assistant Professor, Civil Engineering Department of Civil Engineering Department, Synergy Institute of Technology for constantly guiding me and encouraging me to provide uh, some informations which I gathered during my service careers to present before this technical meet. Thank you once again very much. So now I want to proceed to the topic. Let me share this screen. I think screen is visible to all.
Yes, it is visible.
Um, my topic of today's presentation is beautification of Taladanda Canal using CGCM lining technology in Kotak city. CGCM is something cementous geosynthetic concrete mattress. We normally use geosynthetics in road constructions and slope protection works, but never used in canal. I think it is the first time in India we adopted this technology, geosynthetic mattress in canal lining in Kotak Heritage City. Uh, that time I was posted in Odisha Construction Corporation Limited, Government of Odisha Undertaking, PSU. I got the opportunity to undertake the work because it was new technology, German-based technology. It was adopted for the first time in India, and previous government has interested to modify the Kotak city. It is a very congested city and very old and heritage city also. To give a new dimension to the city, it was decided to take some of the multi-dimensional project together, like canal lining, road activity, construction development, some tourism developmental works. All together, work started, and it completed in a very record time. First of all, Taladanda Canal. Canal, it was a very old canal constructed by the Britishers for their navigation purposes. Now navigation is no more used now. So canal primarily used as a irrigation facilities. Apart from irrigations, it gives industrial water supply to the Paradip, which is located around 80 kilometers away from the Kotak city. So all around the year, gives canal flow is there. So it was very tough to make a closure of canal and construction of activity in the center. So the technology was basically purpose was used to complete the task within a record time. So due to lack of second canal was very since old canal it was lack of maintenance. Canal was filled with garbage habitations was developed in the city center and so many distress hazardous was there. So canal was looking more shabby and unpleasant looks. The canal was looking like this. This was the initial stage of canal. Both side was completely enclosed. Besides, SCB government medical, Kotak is Odisha's largest medical, which is adjacent to these canal sites. So all the medical waste and everything, garbage and all these city centers are there. The people have habits are to dump in the canal. To make this canal, it was a multitasking effort. So canal was looking more of swampy than ordinary canals. It is more looking like a drain. So canal water was also contaminated due to direct discharge of municipality drains as well as government medical wastage. So so due to higher biological oxygen bod value is very high. That's why the color and odor of the water is very toxic. And so decision was taken at the government level to upgrade the medical to a multi-speciality hospital and its surrounding areas to surrounding areas for development purpose. So simultaneously decongestion of cities and the surrounding beautification of medical, eviction of encroachments. So all this task was taken together. 3-lane canal banks, lining of canal from first phase, initial stage we took the stage of 1500 meter. So we decided to renovate the 1500 stage to a pilot basis. If it is success, then we'll do some another stage in pipeline. So the water resource department was assigned to for beautification and improvement of Taladanda canal in a very short span time. As water supply, because water supply is very much crucial during throughout the year, we have to feed water supply to the industry as well as irrigation, both Kharif and Rabi. So department then examined various alternative methods, keeping cost and time, everything. So lastly, we adopted this technology, cementitious geosynthetic concrete mattress, a new technology that is basically European technology and used in Western European countries for slope protection and embankment against slope protection against erosion. Uh, it was as comparatively it was in that it was not only cost effective but also time saving. That was the main important thing. In a record time we completed this project. So water resource department assigned the work to Odisha Construction Corporation PSU to undertake the work. Within 3 months span time we completed the first 1500 meter uh, work, because we took a canal closure for 3 months. So first project it was done. It was started in the year December 2020 and completed by March 2021 within 3 months at the cost of 23.41 crores. So this is the picture before execution and photographs of the canal. This is the head regulator of the canal. This is the barrage. This picture has not completely shown. Here is the zero point of the canal optics. Taladanda is the right canal. This is the Mahanadi river. From Mahanadi river, Taladanda canal originates from Jobra, Kotak. Then it goes up to Paradip. 82 kilometers length canal. So first 1500 meter we took the stretch. It was very hazardous conditions. So before execution, some photographs of the canals I'm showing. This is also before executions. Then we started the work. First, we started cleaning the uh, multitasking efforts because district administration also gives us full support with us. All the pipelines which are connected to the canals. First of all, we need to. It is required to divert these canals, divert those municipality waste pipelines. We constructed some parallel drains along the canal side. Then we first closed all the directly entering into the sewer pipes. Firstly, we closed all these pipes. Then it was rehabilitation. Rehabilitation parallelly district administration helped us for rehabilitating the swamp dwellers because they are almost encroached both sides of the canal banks. It was very tough task to rehabilitate them and resettlement, all these things. After that, we started cleaning the entire canal and throwing the garbage. Again, it was a very difficult task because in the city center there was no space to dump the garbage. So we need to throw it 20 kilometers away from Kotak's city center, where the work was going on. Work was going because the wastage are very hazardous, so we cannot throw it in the city areas. So it was also a very multitasking work that time. These are the some rehabilitation. Government took all the efforts for rehabilitate all the slum dwellers residing both sides of the banks. They built up homes for them and rehabilitated and resettlement their peoples. After closure, water becomes some these days. Once canals, municipality waste pipes are diverted, water becomes clean up to certain extent. Then we come to the CGCM. Before coming to CGCM, I need to show some pictures. This is the CGCM. CGCM is nothing but a geosynthetic mattress. It is a geosynthetics. Left side, this one is GSM. Uh, this comes in uh, rolling sheet. It comes from inside. This is two layer system. This is single layer. This is only used as a separator between base material and CGCM. CGCM this one, and this is GSM. GSM over which CGCM is laid. I'll show afterwards. First of all, CGCM, it is simply a carpet of two layers of high strength woven geotextile. This is made up of polyester and internally connected a regular conjoint or intermittent filter point to release the pore water pressure. Lining, it was why? Because CGCM is something I will show you in picture in details. This one, it has a regular interval. It has filter points where you can release the pore water pressure very easily. Release the pore water pressure for the use under hydraulic load, both longitudinal and vertical loads. It can be used in slopes as well as in beds. In both the ways you can use. The internal space is filled with micro concrete. Micro concrete is used because you cannot insert higher size of aggregate. Normally 10 mm size and below size of aggregate you are using concrete, and has withstand ultraviolet resistance as well as tensile strength. It has some certain tensile strength because it is two layered woven uh, polyester are internally connected at regular conjoint points. When filled with micro concrete, it becomes robust after hardening, and a durable concrete surface appear as erosion protection. The system of geotextile content concrete mattress gives durable rebatement finish and aesthetically pleasing appearance. When it is hardening, it gives a aesthetic and pleasant appearance, because beautification was also considered as simultaneously, because it is since are adopting modern technology, beautification also a important parameter for the reason for choosing this technology. So these are the technical properties. Uh, CGCM double woven layer polyester mattress, weight is 380 gram per meter square. It has tensile strength more than 50 kilonewton per meter square. Spore size 200 micrometers. Average thickness after filling. Thickness varies in the range of 100 mm to 120. That also we are using in the lining. Lining is thickness is after also lining normal concrete thickness also we are providing up to 400 up to 100 mm. So here also we are thickness range varies from 100 to 120 meter depending our requirement. We can material size is available accordingly. This is the oven. This is CGCM, and this is non-oven. Two types of material. One is left side I shown in the figure, that is non-oven, which is called GSM material. Non-oven geotextile. It has that is only using for drain of drainage purpose, because in the conjoined conjoined pore holes, if material should not go away, the main aim behind to prevent the material from passing through the CGCM. So non-woven material is placed below the CGCM material, and concrete grade is we are using M25 grade. Average thickness of coarse aggregate. I told you it was micro concrete. That's why 10 mm and downgraded. And since within the material, within the CGCM, we have to pour the concrete through pressure. So we are not using slump test, because it is a flow concrete. Generally, we are using in the very, and it has some. That's why we are testing flow table test, which should be greater than 630 mm in the flow table test. Admixture we are using fly ash as admixture, and this is the typical section, profile section. First of all, we did not took any lining work in the canal bed. We only took in the slope portions, both sides slopes. This is the CGCM, and this thickness varies from 100 to 120 mm thickness. And below the CGCM, we are providing 400 mm thick for base preparation sand moram admixture. This is laid over the normal slopes or slopes. And canal width is around 24 meter, 25. And main canal, which was that's why it's a very vast canal. So what we did first, we first prepare the slopes. We slopes After slopes we adopted sand moram admixture. Sand moram we took sand 60%, moram 40%, then mixed that separately, and placed over the slope portion, and compacted through compact vibrator roller or compact plate. Both we used simultaneously. This is the arc portion cutting. First we cut the section. First we make the profile section of the canal to as per our design requirements. Then we placed sand moram admixture 450 mm thickness. Then compacted properly over using compactor roller, slope particularly. This is the picture. Then here also you see where the CGCM ends. We made a concrete wall, toe wall. This is toe wall both ends, at the top as well as in the bottom, because it cannot slope. It cannot prevent from sliding. It is main aim to provide restrict the CGCM from sliding both way. We insert the CGCM in both sides of the canal 300 mm, sorry 3000 3 meters from both sides. This and this is also this is key wall we told. This is toe wall. Both ends we are fixed by uh, concrete CC toe wall. That's why we constructed the CC toe wall here, and wherever bathing hut required we constructed. These are some ancillary works we took. After this preparation of slopes, we first applied this 150 woven geosynthetic mattress, which is it is main aim to protect this sand moram admixture, not to prevent because water table is groundwater table is very high. It immediately applying the sand moram admixture. We applied the woven geosynthetic mattress over which we placed this non-woven CGCM material, because this material will not flow away. That's why we applied these materials, geosynthetic materials 150 GSM. It is pervious material. Only water will seep out of this woven geosynthetic mattress, but no soil particles or sand particles will not go away. And over which we laid the geosynthetic CGC mattress, and we stitching as per requirement. We stitch the mattress at the side with the stitching machine as per our requirements. Both sides pegging to hold firmly hold this mattress. Then we apply these concrete, flow concrete, using from ground to top. We apply it from the ground. Then it goes automatically through pressure. At certain pressure, we have to apply the concrete so that it all the pore spaces will filled up accordingly. The material is designed in such a way, the from the very bottom portion we make a hole in the CGCM, then insert the nozzle. Through the nozzle, we supply concrete through transit mixture M25 grade. At certain pressure, the it goes automatically to the top, and after hardening, the surface looks like this. So this looks a very pleasant appearance. Accordingly, um, uh, 200 250 meter we can do in a very one day stretch. We can go complete the, so that's why we complete the task within 3 months. So it was a very rapid process. Shape after concreting. This shape is like this. Through this, this is the conjoint points through which water only come out. Any backwater or pour water pressure, it will release. It will not. Only water will come out and no backfilling material will not go away. That's why we are using this geosynthetic mattress. Both side was looking like this. Then we release the water. After water supply, this canal appears like this in full water supply level. Bed we didn't took any work because due to since the fast this technology was used, and it has no future course of any what, since we are using this technology for the first time, that we decided to do in the slopes only. Beds we did not do because what, due to a high water table in the upstream of the canal, because barrage was very located in the upstream, and pour water pressure release problem. So we do not make any construction on the bed, but subsequently we did it. This is the view before and after. Before, the canal was like this, and we made it like this, and it got huge success. Major challenges was for constructing this project was the eviction of encroachment, which is a vast task, and rehabilitate them to resettlement was also a major challenge. A second one is most important was utility shifting. Lot of in the city center, maximum cabling was going through the underground canal banks, and to shift all the utilities, it was also a major task. We coordinate with the all these stakeholders joint mutual efforts, we can achieve this task. Closing the drainage of outlets of the municipality and it was another task. Then removal of garbage, vegetations, and their disposal. I told you 20 kilometers away, we thrown away all these garbages. And the second one is major challenge was excessive seepage due to higher water table. Since ponding was barrage is located in the upstream of the canal, so groundwater table is very high. So to prevent to release the excess water pressure, we decided to use this technology and the sliding of slopes during constructions, because due to high water table, so slopes was frequently sliding. To prevent the slope sliding, we continuously we did dewatering, and immediately after dewatering, we are applying this uh, GSM and CGCM. So quickly we can achieve the our target. So uniqueness of this uh, technologies, adoption of the CGCM technology in the state for the first time over normal conventional lining, because normal conventional lining it takes very longer times, which we may take 2 to 3 working seasons, and we could able to do in 3 months only. No skill supervision is required, because only slow preparation, and after which we can application of both the materials and pouring concrete, applying concrete, and time saving in construction, water supply as well as water quality of canal is restored. Secondly, aesthetics of this locality improved. A new recreational hub is also created within the city limits. Uh, Due to success, second phase, second 1500 meter we took next year, after taking a canal closure of period again 3 months time period, that also we finished. Third phase also, that time it was going on and I left this place, but now it has already completed. Third phase already 500, already 5 kilometer stretch. CGCM lining has already been completed as on today. This canal is just like this. So our secretary has told a very sensitive task. This even a difficult and sensitive task can be achieved by meticulous planning and stakeholders' confidence, because R&B did his job. This constructed this both side parallel roads, 7 meter wide roads, because to find a road, another driver the traffic. It was a distant dream for the Kotak users. And yesterday, this is the view of yesterday, because the historic Bali Jatra, Asia's largest trade fair, was going on, and the canal was fully illuminated using lights. I came through the canal, and the view was very interesting. It gives us immense pleasure. So I took some photographs. I told someone to take the night view photographs. They have sent this, and their canal also itself we promoted to tourism, uh, because boating already tourism has already created a boating uh, center in the canal. Never dreamed that in the canal one day boating will go on. That also comes success. So this is all about my topic. I like to thanks. This is a small example, because normal conventional lining we are doing everything. This technology you can do a very short span of time, and since canal closure is difficult to take all time, so we can, it is better to, it is achieved this task using this technology only. Otherwise, in normal conventional type, it could have much mm, time taking process. I like to conclude. Thank you. Any questions you can ask me, sir? Hello.
Yes. Yes, yes. Hello.
Yes, sir.
So actually, your topic is totally completed.
This is a small topic because it's a new technology and it has nothing to do with
Another is your irrigation system. I think piping.
irrigation. Sorry.
Now we can conduct the questionnaire session because this is the 6 to 7:30 the session is. So any doubt from the uh, our participant side? So this is a new topic also. They can discuss with our expert. The participants.
Sir, good evening.
Good
Sir,
evening.
good evening. I
Good
am having
evening.
certain questions.
Yes.
Can I ask now, right now?
Yes. Yes. Please.
Sir, laying and fixing of CCGM,
Yes.
if you
Physician.
compare with concrete lining,
Yes.
then which is the costlier?
Normally, this project was taken as a pilot project basis, and it has a monopoly because no one European. This is a European technology, and one vendor was selling this product, and that's why the project is two times higher than normal conventional lining. It can cost can be reduced depending upon the availability of product in the market.
Sir,
Because
another question, sir.
yes, sir.
Whose lifespan is more? If you lifespan of concrete lining and CCGM lining.
As per company's recommendations, it can sustain up to 20 to 35 years. Sorry, 20 to 30 years. Since
Sir,
we adopted this project in the year 2020, it is still in good conditions. Normal lining also they are also goes up to that 20 years maximum. But this
sir,
is a
another
this
question.
yes
Sir,
please.
another question.
Yes.
Is there any plan of extension of CCGM for rest of Tardanda Canal?
Yes. First project was taken in pilot basis for a stretch of 1500 meter. After its success, then government decided to took another 1500 projects next in pipeline. So in the second year, we took another 3 months canal closure, and we did another 1500 meters. Third year, we took closure. We did 2 kilometers. Totally 5 kilometers we completed in 3 years,
Sir,
which is already almost city was covered. Inside the
sir,
city, it
sir.
was planned for beautification purposes. Both the purpose was solved. We did beautifications and we completed in the shortest span time period.
Sir, is there any planning for Puri Canal?
The, yeah, again, please, sorry.
Sir, thank you, sir.
Sir,
I may,
sir,
yes,
I have a question.
yes,
Can I ask you, sir?
yes, please.
Sir, the concrete used in this technique, is there any specification for this concrete or in
Yes.
which
Because
grade?
we are using micro concrete. Micro
Sir,
concrete is different than the normal concrete because it is a flow concrete. It has a very slump test is very high, 630.
sir means it is a one type of self-compacting concrete like.
Self
Uh,
compacting, no compaction is required. That's why
sir,
we are using higher grade of concrete M25,
sir,
and it self compacting, and
sir,
after
the grade of concrete is M25.
M25. We
Yes,
can
sir.
go also even higher, but we decided to do it M30, M25 concrete.
Yes, sir.
Huh.
Sir, another thing, sir, it is a self-compacting concrete. or not?
Yes, it is fully self-compacting. You cannot
Sir,
compact.
what kind of super plasticizer used in this concrete, sir?
I told you,
Sir,
super plasticizers. 1 minute. Admixture we used fly ash. Super plasticizers, as per the requirements, we used because we set up the plant near the side of the canal.
yes, sir.
So travel time was within 5 minutes.
Sir,
Achieved.
but according to that European code of self-compacting concrete,
Yes,
there is a super plasticizer is used according to the binder ratio of the concrete, that is 0.09 to 0.1 something in this ratio, sir. So, sir, I just want to know that what kind of super plasticizer used in that particular kind of concrete, because it is a very new technique for us, sir.
right. Actually, we also followed all the codal requirements
Yes,
of
sir.
the concrete of for self compacting concrete. All variety kind of super plasticizers are available in the market.
Yes,
And
sir.
as per the requirement, we are using in the site plant site because it was easy for us to have the supervision because we set up the plant to the adjacent to the canal site so that our people can have always monitor these uh, our requirements.
Yes, sir.
Exactly, I cannot tell you what kind of super plasticizers we are using because variety of super plasticizers actually are available in the market.
Yes, sir.
But they are using as per the requirement of course.
Sir,
I
sir,
think
another question is there.
company name I cannot remember. I don't remember exactly the
Yes,
name
sir.
of
Sir,
the company.
another one question, sir. Sir, is there any durability test conducted on that particular type of concrete?
Uh, Durability once because we were also using flow table test
Yes,
as per
sir.
the requirement every I think every day we used to do flow table before commencement of work, during execution, after execution. But
Sir.
what is it? Every lot we were using the test. Once
Yes,
concrete enters through the CGCM, we cannot test any further because it has already very small thickness. Lining
yes, sir.
thickness is very small, 100 mm.
Yes, sir.
So it can sustain lining. Safety of the lining depends upon the your filter arrangements. If you
That filter
float
media provided between the soil and concrete.
right,
Yes,
if
sir.
you allow the water to drain freely, it will go for a longer period. If you will restrict the flow, then it can damage everything. So
Sir, sir,
this has all the conjoint points. So water was releasing freely.
sir. Sir, is there any seepage criteria to for the embankment through this permeability test of the concrete like that?
Again, please, sorry.
Sir, is there any test conducted for the permeability of the concrete or water seepage through the embankment?
Permeability of concrete, normally we do not um, do at the site.
Yes, sir.
Nowhere,
Nahi,
I don't think permeability we do measure at the site. But seepage, since water body was located above the uh, upstream of the canal, because I told barrages is situated in the just head of the canal. So
yes,
water
sir.
level was very high. So seepage test was conducted. Seepage since higher seepage value, it was very difficult to place this sand marm admixture, and it was going to slip away every time.
Sir,
So we did pumping arrangements and all these things.
sir.
After
Thank you,
as
sir.
soon as pumping water is drained out, we applied this both the materials and placed the concrete immediately, so that it is the water comes out through the pore pressures and product remains stable.
Thank you, sir.
Sir, any other suggestions? Any other?
Any other question from our participants? Any other question from our participants?
Sir, good evening, sir.
Good evening.
Sir, I have one doubt.
Yes, please.
Sir, is there any scope of controlled discharge, groundwater recharge?
Groundwater recharge.
Yes, sir. Because we are
Here,
facing
here we did not require any groundwater because already groundwater is already high. Since water body was above the full supply level of the canal, water table, groundwater table. So no need
no,
of
in summer, sir, there is actually very less water table going down. Yes, sir.
No, no, this region particularly water table was already high because since barrage is there, ponding was done up to full FRL level.
Okay, sir.
FRL level is much higher than the FSL of the canal. So no
Okay, sir.
need to do any groundwater recharge, but automatically groundwater automatically comes through pore water pressure releases. We have to release the pore water pressure.
Okay, sir.
Uh,
Thank you.
Sir, I have another one question, sir.
Yes, sir.
Sir, the membrane used in that particular as a filter material, and the another membrane also, I think that another membrane also used to cast the concrete. No, sir, only one membrane used as a filter
No,
material.
two membranes.
Two membranes, sir.
One is woven materials, which is called non-woven. First, that is called GSM.
Yes, sir.
GSM was used to filter the water
Yes, sir.
through and then after GSM we are applying CGCM, over which we are placing the concrete. And
Yes, sir.
CGCM has regular intervals for water pressure releasing valves.
Sir,
So water
GSM, the full form of the GSM, sir?
GSM,
GSM. Geosynthetic material, sir.
geosynthetic mattress, very 150 micro,
150 micro, sir.
huh. So water only come out, no slope material will go away. Our aim was to prevent the slopes
Sir.
to flow away.
And the second material, second layer, sir?
Second layer was CGCM, over which we are placing concrete. That was here. This is GSM.
Yes, sir.
We are applying overslopes after application of sand borough admixture. We are putting this one. Because whatever the seepage water is coming, it can come out through this mattress. Over which this application of this CGCM, this is double layer.
Yes,
And
sir.
it has regular interval points over which concrete can flow from bottom to top.
Yes, sir. Thank you, sir.
This one. This one.
This one, sir.
We are placing this GSM materials first.
Yes, sir.
Then over which we are placing CGCM.
Sir. After that, through that CGCM, you concrete pumping
CGCM, we are pumping concrete.
concrete through that layer, sir.
So whatever the water will come, it will first filter this through this GSM. Then
Sir,
again,
that means there is no curing required for this concrete?
we are doing the curing.
Sir,
The concrete for durability of the concrete, curing must be done.
sir, in which way, sir? Because a membrane also present in at the top layer of the concrete.
Yes, but membrane on the top of the layer, we are using fully covered through the gunny bags. Gunny bags
Sir.
and application of water continuously.
Sir.
But it is this is but you can say it once it is concrete enter inside, it becomes appear like this. This is the construction stage. After
Sir.
construction stage, this look like this. Look
Sir,
like this.
my,
If you apply the water over this, it will penetrate
through that layer, sir.
through that layer.
Yes, sir.
So
Thank you, sir.
yes. And
Any
Hello,
other
sir.
question?
Hello, sir.
yes, sir.
Hello. Sir, I have a doubt. Sir, how
Yes.
long does the CCGM lining last?
It can last, as per company specification, it can last minimum 25 years.
Okay, sir.
Since we have adopted this technology for the first time, we can assess its lifespan after its passing of 25 years. Before that, I cannot say because it is already in good conditions. But at these regular intervals, sometimes it is filled up by the sands, whatever is coming. If any silt are coming through the canal, it may sometimes deposited, but through application of pressure pipe, this is being released, washed away. Washing is done every time, every once in every year to release any silt deposited in the pore spaces. Because if it is deposited, water cannot be freely drained. So regular maintenance we have to do.
Okay, sir. So, thank you, sir.
Sir, I have a question, sir.
Yes.
Sir, can any other material be used for this purpose? Any other material can be suggested for this purpose, sir?
Lining can be done. There are also new technology have come to the market. Lining it all depends companies specifications requirements. Since we have not adopted this technology, we adopted over normal conventional concreting, and it was simple to execute. No need to skill supervision is required, and all these things. Other techniques in geo different types of geo materials are nowadays available in the market. They have also their companies they are showing presentation. Sometimes they are using at different states of India. We have not adopted, but it is available in the market.
Okay, thank you, sir.
Any more question? Any more question from our participant side?
Education work also done at the same time.
Any more question from our participant side?
I think I conclude very least time because this technology is nothing to give much importance.
Okay. Can I ask, because I am the coordinator of this program.
Okay, sir.
So I am just asking a question.
Yes, sir.
As you mentioned that the Taladanda canal is of 82.5 kilometers long.
Wrong.
The length of the canal is 82.5 kilometers.
Yes, sir. Originates at Jobra, goes up to Paradip.
From Jobra to Paradip. So whether government of Odisha has decided to go for this canal lining up to that 82.5 kilometer length or in urban areas only?
Since this product, sir, this product is since 2 times higher than the normal conventional concreting. Only decision was taken to undertake this CGCM lining in the urban areas. Then rest of the areas, government is doing normal conventional lining in phased manner through Mukhyamantri Canal Lining Yojana, Navakushna Chaudhary Yojana. We are also doing here at Nimapada canal lining through Navakushna Chaudhary. Number of canals stress normal conventional lining we are using. We are not adopting this one. This was a project only implemented in the Cuttack city. as a pilot basis for beautification purpose.
Okay,
Time
so
was,
mane,
time was restricted because within the 3 months we have to complete the task. Because water
okay.
supply have to be restored in the canal for industrial water supply to Paradip. That was the main prime important factor, because Rabi irrigation closure we had taken that year.
So during heavy flood condition, during
Yes, sir.
the high flood condition, so such type of lining that is provided in the canal, uh, can it prevent the force due to high flood? Can it give any type of guarantee that there will be no separation at a particular junction in this canal?
Sir, first of all, canal.
Particularly,
Sir,
as we know that during high flood in Baleshwar or Bhadrak or Jaspur, some parts of the um, uh, our some parts were broken and flood water entered into the city. So, is there any chance during such type of flood condition, it has impact on this particular portion of the canal which is lined by these geosynthetic matrices?
sir, first of all, canal is a control structure. We have a control structure in the head regulator. First of all, when there is heavy flood, we close this canal system fully and allows the water to go in the river. So we do not allow the flood water to pass through the canal.
Okay.
So once flood will go out, it will be washed away. There is maximum chance these things may, because flood has predominant uh, velocity. It can do any disastrous to anything. So since it is a control structure, we always try during time of high flood, always canal system we try to close this head regulator. We do not allow flood water to enter into the canal, because maximum FSD we can allow to pass through the canal.
Now, when the river, the full sea level of FSL of the river, if the flood water moves over FSL level of the river, then that will enter into the canal.
Sir, when the high
Suppose,
flood
suppose, suppose
sir,
Hirakud Dam has a particular capacity,
yes, sir.
and accordingly, in a controlled manner, the dam is discharging water, and the same water is again controlled at Munduri, and it is again discharged to Jobra. Suppose some type of natural calamity, we don't know what type of disaster and disasters will occur. Suppose that type of situation will come, and the flood water the surplus water will enter into the canal. So, can this material prevent?
Sir, when there is a breach in the river, the water may come and it can damage the canals. There is maximum occurrences during my service career. I have seen breaches has been occurred at many places in the canal during the time of flood. So immediate steps have been taken to restore this canal again its original shape, and we do some maintenance repair work immediately. But
The
we have never seen in last 5 years, flood has come into the Cuttack city.
because the flood water is checked, the flood water is checked at Munduri. That is why.
Actually, only they are diverting the flood water at Munduri. They are not checking, because whatever, because only reservoir you can manage you can control the flood water. Reservoir system
Yes.
is only at Hirakud system.
Yes.
Once it is being released, it has to be passed. because in Hirakud system, maximum flood, observed flood in the year 2008, we have seen 14 lakh cubic. At that time, maximum effort is being given. Is there any chances of a breach or anything hazardous? Knowingly or knowingly they do at they try to uh, make breaches at remote places where there is least devastation. But the city, if flood water enters into the city, then huge life properties will be devastated. So normally we don't
Okay.
allow to enter the flood water in the cities. We
Okay.
try, if you allow, then we have to breach at some other locations where water can be go. It can paddy crops where least people will get affected. That area we try to suffer. But city nowadays cities are suffering because of flash rainwater.
Flash flood. Flash
Then
flood.
flash rainwater. Heavy rainfall occurs. Then flash flooding comes due to improper drainage. It is being seen. But due to high flood, never there is least chance of water entering into the cities.
Okay. What is the maintenance period of this system?
Every year we do maintenance. Maintenance
Okay.
is the same because if the void spaces, sand get deposited from the sand, uh, grass comes out. We do removing the grass oftenly. Otherwise, this system looks odd. So more proper care we take, then it can go more. It can longevity can be better.
So every year the maintenance is going on.
Not necessarily every year, but we have to do at least 2 to 3 years. We have to regular routine maintenance. We have to do. Otherwise, grass will fill up everywhere. Yesterday, this figure you can see. Last one. At the some intervals, grass is green is looking because this is filled with grass. Some regular
Okay.
intervals. So that need to clean at regular intervals. Otherwise, this is look something different.
What is the difference in cost? What is the difference in cost?
Normal
For,
conventional lining and CGCM lining cost is 2 times.
per meter length. Per meter length. What is the differential cost?
But it can cost can be reduced if this product is widely available and monopoly system will be go away because one company is selling the product.
Yes.
If it is locally available, that then the more competitors will come out. The cost can be go further reducing.
As you are associated with these works,
Yes, sir.
so I think you better know what is the cost per meter length of conventional lining and cost per meter length of this geosynthetic matrix. What is the cost for 1 meter length of this geosynthetic matrix?
Synthetic
Cost per meter length.
actually cost depends upon the materials. First of all, we use GSM materials. GSM per square meter rate comes around 85 rupees. This one,
Okay.
GSM, this one GSM. 150 GSM per square meter rate is 85 rupees, right? And this CGCM material, which is GSM is widely used. That's why rate is very less. And CGCM it is not widely used. It is manufactured at Germany and supplied to with rolling packs, rolled packs here like this, rolled packs. And this cost with transportation to us, it gives us around 1500 per square meter.
1500 per square meter.
Square meter, CGCM, this one.
Hmm.
Then concrete cost, concrete self-compacting concrete, this cost around 7,000 per square meter. Then it comes sand, moram, and mixture, all these things. This is the normal rate whatever adopted in the government practices were used of.
So
But this
overall,
cost,
for one meter square meter, it is about I think 10 to 15,000 rupees.
yes, sir. But this cost can be reduced if it is supplied widely as per demand requirements or local markets available. This can go for the reducing. This is available everywhere, but this is not available. Inside this geotextile, this is like this. Both are interconnected by this textiles, and these are some tensile strength. It can bear certain tensile strength.
What other conventional methods are used for canal lining
Normal
instead
concrete
of this?
lining.
Instead of this,
Normal concrete lining is the conventional lining we are using. We are using pressure
uh,
release valves. Normal conventional lining, concrete lining, where we are using M15 grade concrete, and thickness varies depending upon the discharge of the canal. Thirdly, pressure releasing arrangements, we are using sorry, pressure releasing arrangements, we are using PVC, perforated PVC pipes. Nowadays,
okay.
PVC pipe substitutes is also available. UPVC pipes has come, and it can give better lifespan, higher lifespan. So here the problem is we are not giving any filter arrangements because it has filter points.
Hmm.
Conventional lining, we give more stress on focus on water draining arrangements. How much pressure release valves (PRV) at slopes, at beds we have to use for releasing pressures.
The main objective of lining is to prevent the sidewall, the embankment. It is the main objective of lining. Am I right?
Lining increases water
The,
efficiency.
the erosion of embankments. That is why we do general lining in a canal. So, um, if that is our purpose, this is my question. If that is our purpose to prevent the embankment of the canal, so is it viable to adopt this process? Because we are providing this in urban areas, and as you said that generally urban areas, the canals in urban areas are not highly affected. So if this can be applied in rural areas, that will be, I think, a better solution for the lining system. In urban area, this is for beautification purpose.
Yes, sir,
Because
exactly. I do agree with you, but the problem is the cost. It should be first of all cost effective. Cost effective, to make it cost effective, product availability is first and foremost things. Second one is once we go for conventional lining, more skilled supervisions, so pumping arrangements, drainage filters, and everything is taken care of. Which we normally have least time to focus on contractors. Usually, he does his work very haphazardly. Whenever site engineer is not at present, I don't know what he is doing. So problem, but this system, no skill supervision is at all required. Only to make profile the canal is once you done the profile of this canal section, then application of this product is very simple and uh, done in a very quick time. Where
okay.
you can use it in the urban area or a remote area, there is no difference.
Uh, exactly, I could not remember. I think during my visit to Mumbai or Hyderabad, exactly, I cannot remember. I have seen there the canal, the total stretch of the canal is adopted with this system. Why not government of Odisha is taking care of this? Because we have sufficient funds. And if we will go for total lining, it will be, I think, a better solution for the peoples of Odisha. I think in Mumbai or in Hyderabad, exactly I cannot remember. Already this system has been implemented for the total stretch of the canal. I think during my visit over longer length, I have seen that already these works have been performed there. So if they can go for this, why not government of Odisha is taking care of this
Government of
one?
Odisha is taking much advanced decisions and doing this. Actually, due to lack of fund availability, government is doing certain stretch of canal where vulnerable frequent breaches is going on. They are doing where water is constantly depositing, not flowing properly due to other reasons. That stage we are adopting in the phase wise in normal conventional using, because cost is also taken care of at the same time, because if we will go this product, it again cost is twice. I'm not telling this product is bad, because due to non availability and one man's product, the cost is high. Once it is available, people will start using this cost will go on further reducing, then cost will come out reducing come. And other countries, their government decision is different. In our countries nowadays, whatever the canal system is there, we are government is taking decisions to upgrade these canals to the lining. Main canals, first of all, they are doing all the main canals and branch canals fully lining,
Okay.
because water should reach to the farmers immediately after supply of irrigation. A lot of losses are being done, seepage losses, conveyance losses. So flow velocity, normal earthen canals flow are design flow cannot be achieved due to vegetations, weeds, and all these things. So lining once we done, these things irrigation facility can be much improved.
Okay, thank you very much, sir, for your solutions to the users. And if any more question is there, so the participants can discuss. Otherwise, we will close this program. So no more question. Okay, being again the coordinator of this faculty development program, I want to say that I am very much thankful to our speaker of the evening of the first session, day 5, Engineer Pritam Chetan Pothal, sir. Yes, nicely presented the topic and very informative, a valuable topic. So everybody should know about this canal lining, because we know in the previous system how the lining was going on, but now some modern technologies we are using. Anyhow, I am again very much thankful to our speaker.
Thank
So
you very much once again. I like your
very
valued
informative. It was actually very informative, because
and that I could
all the civil engineering peoples, they are going for this structural approaches, that transportational approaches, that mm, environmental approaches, but irrigation, this is not only our purpose is not to irrigate. Our purpose is to save the flood control, the flood routing, and how to save our crops. So everybody should give importance on that, and really very informative session, and I am thankful to you, sir. So, with your kind permission, we want to
Very much,
close this
sir.
program.
Glad I could able to share my experiences, little experiences, and I got some valued feedback from your side. Some good interactive question hours took a very longer time than the presentations. I hope next time if any technical meet is there, I will come with different solutions. I will try to bring with different.
You are always welcome, sir. You are
Thank you.
always welcome.
You
And
are
after this FDP, also I'll request you to give some technical session to our students of civil engineering department.
definitely
Senior.
it's my pleasure. And last but not least, thankful to you very much, and also to Mosumi, Engineer Mosumi. She has whatever I'll tell about her, it will be least. Credit goes to her. He constantly motivates, encouraging me to since last 3 to 4 months. I could not, despite of my busy schedule, I could not able to answer her properly. So I'm sorry, extremely sorry for that. And once again, I like to thank all the members participated here. Thank you very much. I like to conclude. Thank you.
Thank you.
Thank you, sir.
I'm leaving, sir.
Okay, thank you, sir.
Okay, sir.
Hello, good evening, sir.
Good evening, sir.
Okay, a very good evening to you and again all the participants present for the second session of our day 5. So my duty is to introduce our speaker. Yesterday already I have introduced our speaker to all of our participants. Again also I am just briefly introducing our guest today, Dr. Priyadarshini, working as assistant professor in the Department of Civil Engineering at Institute of Technical Education and Research, Shiksha Anusandhan, deemed to be University Bhubaneswar, and obtained his PhD in Civil Engineering from National Institute of Technology, Rourkela, specialization in structural, and the focus area is static and dynamic behavior of laminated composite structures. His research expertise includes vibration and buckling analysis, structural health monitoring, stability studies, and the application of intelligent computational tools such as fuzzy logic and artificial intelligence in structural systems. With over a decade of teaching and research experience, Dr. Das has guided several undergraduate, postgraduate, and doctoral scholars. He has contributed over 30 peer-reviewed journal papers, book chapters, and conference publications, reflecting his active engagement in research. He also served as the convener of the first international conference on advanced technology in material science and engineering, ICAT-MSc 2024, successfully organized at Institute of Technical Education and Research, Shiksha Anusandhan, deemed to be University of Bhubaneswar. Dr. Das' current research interests include composite and sustainable construction materials, vibration-based damage deflection, and AI-assisted structural performance evaluation in the field of civil and material science engineering. So, our speaker will deliver a very informative topic today, and the name of the topic is fuzzy logic based diagnostic approach for crack detection in laminated composite beams utilizing dynamic and stability responses. So once again, I welcome you, sir, to our second session of day 5, and I request you to start the session.
Thank you, sir. Thank you for your introduction once again. And been privileged to present my topic today. Let me share my screen, sir. Is it visible, sir?
Yes, it is visible.
1 second, sir.
Visible, sir.
So does the slides are moving, sir?
Slides are moving.
Is it on
Yes, sir. Yes, sir.
is it
Yes,
on
sir.
the
Slides are moving.
is it on the presentation mode, sir, only, na?
It is presentation mode.
Oh, thank you, sir. So my topic for today is the physiologic-based diagnostic approach for crack detection in laminated composite beams using dynamic and stability responses. As we have discussed yesterday, how the vibration and buckling behaviors are affecting the laminated composites, and through those analysis, how inversely we can find, inversely we can detect the damages inside the structure. So sometimes it is visible, sometimes it is not visible. Actually, when the laminated composite is being fabricated, so through vibration and buckling, there is a chance of, or there is a possibilities of, for intra-ply failure and inter-ply failure. When this is an inter-ply failure, that detection, the detection of those inter-ply failures are not visible through naked eyes. When this is the intra-ply failure, through that vibration analysis, we can detect where the vibration is shifting or the frequencies are shifting from intact state to cracked state. So analyzing those frequency behaviors will enable us to identify how the cracks are behaving and where the crack is situated. So that means the crack severity by its position and by its depth we can measure. So integrating the artificial intelligence technique like physiology, so it is convincingly we can identify the structure where the damage could have been more severe. So continuing this presentation, so these are my content layers where once again the need for the composite and how cracks are being affecting the structure. Then the design of materials, and through the material informatics, we'll find how the material is suitable for the analysis, and what are the artificial intelligence techniques and the physiologic based diagnostic framework, then what are the data, and summarizing all the concluding all the summarizations there. So importance of composite laminates, that already we know that this is high strength to weight ratio and high strength to stiffness ratio. It is the ability of tailor the composite to different shapes enables the engineer to provide its applicability in different engineering fields. So laminated composite can be shaped into the beams. Laminated composite can be shaped into different forms of plates. It can be cell structures are also. So conveniently, it can be applied through different engineering applications. So that enables the improved tailor properties, that is translated to the weight sensitive and cost effective material. Then it is also, since this is a tailorable property, and since it is tailorable and weight sensitive, it can be applied through different engineering fields. So that is composite laminates carries a lot of importance in such fields. So laminated composites, as we have discussed yesterday, it have in two phases, that is fiber phase and matrix phase, where fiber predominantly transports the load and matrix predominantly distributed the stresses between the fibers, thus protecting the fibers from the environmental loading conditions. And when we are when we are fabricating a laminate, the laminate should be fabricated in such a way that maintaining the pressure and room temperature, so that the bond between the layers should be uniform. Maintaining the uniformity between the bond between the laminates is very important. So now the concept of structural health monitoring. The structural health monitoring means if the structure is designed for a particular period, then for that period, the structure encounters different kind of loading conditions, from the environmental loading condition, static loading condition, dynamic loading condition. On that repeated action of load, how the structure is behaved through the edges, that need to be identified. Because if you are not going to identify the structure's health, then the crack initiation may be propagated throughout the structure and ultimately the failure will happen. So for those things, the structural health monitoring is an important aspect for the designing of the structure. Actually, nowadays, structural health monitoring is the essential part for every built-up structure. So structural health monitoring essentially integrates the sensor data that for the real-time monitoring and the assessment of the structure for ensuring the safety and performance of the structure throughout its life period. Wherever the crack or structural disintegration happen, that can be identified easily, and depending upon the severity, we can address the structure about its functionality. So that's why structural health monitoring carries a lot of importance in today's structure. So in structural health monitoring in laminated composites, because the laminated composites, it always consists of the hidden internal damages like delamination or crack between two fibers. If the matrix somehow or for some reason matrix is the bond between the two fibers, it is not adequate, the matrix is detached from the fibers. So at that point the delamination happens, and through the repeated action of load, cracks are always formed. The structure is susceptible for the cracks or disintegrations through the repeated action of environmental load conditions. And again, laminated composites, the failure modes are very complex due to its orthogonality. The orthogonality properties presents a complex failure modes in layers, each layer having susceptible for the failures. That means here the intraply failure also happen or interply failure also happen. And due to its wide applicability in different structural applications like aerospace and civil engineering field, mechanical, agricultural field, it carries a lot of importance towards its structural health monitoring. And whenever the structural disintegration happens, the stiffness of the structure reduces, and thus it will affect the vibration behavior. That's why. So by research attention towards the vibration analysis or crack detection technique in laminated composites, as you can see that from the reputed literature, so those who have addressed the meticulously addressed the vibration based crack detection technique, and we can see that the modal curvature or wavelet based method, that is 25%. Strain energy or complacement, that is 20%. Ultrasonic different non-destructive testing techniques is 20%. All very AI generated. AI is quite new to the laminated composites, though it has been implemented in different structural applications, but through AI generated crack detection technique in specifically laminated composite beams, it has not attained much wider field. That means if I'm saying that the AI generated field, that's physiology, advanced neuro, that is ANN or machine learning. For machine learning, it requires a huge number of data. So with a small amount of data, it cannot generate a robust model. So for those things, Logic received a wide attention because of whatever the data we are inputting, those data can be amplified through the rule-based methods. So we can say from this research attention that the AI-based technique used for the crack detection or damage detection in laminated composite beams or composite structures is far from complete. So it has to gain lot of attention. So now again we are discussing about the design of materials that indicates this explains that the key selection material that is grouped in three parts, that is general, mechanical and thermal properties, where the behavior of it can be understood the behavior of the material, that is the stiffness, its brittlety, its ductile, and how it has been changed, it is respond to the temperature changes through thermal expansion and thermal conduction. So basically it gives an idea. So how to compare two materials about its performance or performance related parameters for the engineering design. So explaining this, suppose we are having a aircraft wing. If it is not adequate for its stiffness, strength, toughness, and weight, it will break. So that means the properties and performance of the aircraft wing depends on the balance properties or balance design of its stiffness, strength, toughness, weight, and also it is the fracture index. If it is not addressed properly, it will break. The smart design of materials through the material informatics, that the material innovation of the infrastructure. It integrates the computational tool, experimental tool, digital data, and that will help to find the suitable material that will essentially serve for the human welfare, or essentially it will the material that will serve, or that material as the building material or a construction material or a structural member that can be served as the human welfare, for clean energy, for national security, and for the next generation workforce. The informatic based design, that is integrates the data, correlated data, then theory, and it must be knowledge based. So the data that can be the data acquisition from the experimentation or literature or numerical analysis or design of the materials, then the correlation with the physical concept of the system, then theory, that is informatics based materials design. So how the material is designed and how the material is compared for its performance based design. So that informatic based design enables the engineer, enables the designer to use that composite material for the structural application by comparing its performance based design. The brief introduction to the artificial intelligence. So artificial intelligence nowadays gaining a lot of popularity, and towards the structural application. So different artificial intelligence techniques are there. Machine learning, that is one of those that is widely used, and this machine learning, search algorithm, and other techniques. In machine learning, we have artificial neural network, ANN, deep learning, principal component analysis, Bayesian model averaging, support vector machine, random forest. Then for search algorithm, by optimization method, we get genetic algorithm, the genetic programming, and other techniques we are using fuzzy logic. So for our study, we use fuzzy logic. Actually, the genetic algorithm also can be merged with fuzzy logic, and the advanced neural, so artificial neural network also can be merged with fuzzy logic. So fuzzy logic is a fuzzy logic is an effective and very good artificial intelligence technique which requires human-like thinking. So this with fuzzy logic, we can turn the numbers into fuzzy linguistic meanings. That means whatever the human thinking does, or whatever the human thinking is there, that human thinking interpretation through the artificial intelligence technique, we got the output value. So how it works? So this is the elementary architecture of the fuzzy inference system, where the crisp inputs are there. The crisp inputs are then fuzzified through the if-then rule. If-then rule means, so that is, if the stiffness drop is high and the vibration shift is medium. If the stiffness drop is high, vibration shift is medium, then we can say that the crack severity is low or high. So like this is the logical reasoning where we input the values. That's the crisp input values. Then through the if-then rule, we are getting the fuzzification, and through that analysis, then that fuzzification is defuzzified. Then this defuzzification will provide the crisp outputs. In defuzzification, actually, the number of rules that can produce a number of outputs. Those number of outputs are clubbed together to produce a generalized output. That means for the crisp inputs, suppose I have given, in my study, I have given the frequency analysis, the frequency values, frequency 1, frequency 2, frequency 3, frequency 4, all those frequencies for a different set of analysis is analyzed through that if-then rule. Then this is fuzzified, and for each frequency, whatever be the outputs are there for the crack location or crack severity, that crack severity, the crisp output gives as the only one value. Out of hundreds of value, that will give one value, which is more accurately or more closely resembled to the numerical modeling or experimental analysis. We'll discuss it further. So fuzzy logic for the crack detection, that is the soft computing application towards crack detection using fuzzy logic can provide a significant information and knowledge. The application of fuzzy sets offers significant and relatively newer modeling and reasoning pattern in the framework of uncertainty. That means if in the fuzzy inference system, if you are if the input values are very uncertain or noisy, it is independent of that uncertainty and noisy values. We may get the value for the frequency at a very noisy environment. So that noisy environment may tamper the frequency approaches. Sometimes when you are getting the frequency through the modal analysis, the leakage of the signal or the aliasing effect of the signal may distort the frequency values. Even if we are providing that distorted frequency values, it is independent of that distorted frequency values. So those uncertainty and noisy patterns are, the fuzzy logic is capable of analyzing the noisy patterns. So it is a possible alternate just for substitute of the classical ideas for logic and membership application at the prototype edge of the artificial intelligence. So it is the form of artificial intelligence where human thinking is the most important. It follows a fuzzy rule that entails the representation of human expertise. So whatever the human expertise regarding the knowledge being presented through the numerical analysis, presented through the experimental analysis, presented through that thumb rule, it interprets those values, and through that defuzzification, it will provide the output. So this is the architecture. So this is the architecture for the fuzzy logic for the crack detection, and it used the if-then rule. So the input distribution of x and y where output distribution will get the merging the AND rule, and then we are getting the values. So like I said that if the stiffness drop is high and the vibration shift is medium, then the crack severity is high. So it is written that if the stiffness is high, stiffness drop is high, and the vibration shift is medium. Suppose I am saying that if the stiffness drop is medium, and the vibration shift is high, then what should be the crack severity? So I have to write that input value. If the stiffness drop is high, if the stiffness drop is medium, and the vibration shift is high, I might write the crack severity is high, crack severity is low, crack severity is medium. And through that analysis, through that framework, fuzzy logic analyzes what should be the best pattern if the stiffness drop is medium, if the frequency drop is high, if the frequency drop is medium. What should be the best pattern most suitable for that case? If I'm saying that from the yesterday's analysis, when a crack for a cantilever beam, if a crack position is nearer to the support, it exhibits the maximum reduction in frequency. So I can write that if the crack location is nearer to the support and crack depth is about 0.325 or 0.315 or 0.375, the crack severity is maximum, or crack severity is more. Then for the same point, I can write the crack severity is low. For the same point, I can write the crack severity is medium. It will analyze all those three things: medium, high, moderate, or medium, low, moderate. Then accordingly, all the input data and whatever the rules has been written for that, analyzing those rules, and for that input data, it will produce the output distribution. So whatever be the input distribution, for that rule strength is quite important. Number of rules, more the number of rules, more crisp will be the output distribution. Crisp input means number of inputs you can put, but the rule strength must be higher. The rule strength is so high that the output distribution will be much crispier and it is much closer to the experimental analysis. So in this way, this is the mathematics and which the logical reasoning for which the fuzzy membership works. So according to L.A. Jade, the fuzzy set P of set R can be defined as this. So this is the what is the core concept of the fuzzy logic inference system, or FIS. Shortly I can say that FIS. The inputs that are extracted features including crack width, length, depth estimates, and texture intensity measured from the processed images. So here for a presentation approach, images can be analyzed through the fuzzy logic. The fuzzy processing that includes the membership functions, classify numeric features into linguistic variables. Linguistic variables are most important thing, because if you are not going to define what are the linguistic variables for if the linguistic variables for the rules, if the position is nearer, what should be the value for that, or what is the severity of that crack, high, low, and the output values that precise crack presence detection, location mapping, and severity estimation for the structural assessment and maintenance plan. So that means depending upon the CRIS inputs, the outputs will be generated. And for that, between that input and output, the rule strength must be so high that it will generate the CRIS outputs in the form of crack detection, location or position of the crack, severity of the crack. The fuzzy inference system bridges the gap between raw numerical data and meaningful structural health assessment by handling uncertainty inherent in a real-world crack detection. So whatever the raw data we have, by inputting those raw data, number of data that is be processing through fuzzy processing, and the outputs will be crisp outputs. So how the simulation process works. So this fuzzification step that converts the crisp numerical inputs to fuzzy sets. The crisp in numerical inputs such as measured craft depth, vibration frequencies, and buckling simulation, buckling results, critical buckling loads, nonlinear analysis, nonlinear vibration frequencies. So this means instead of treating a value as strictly a high or low, the fuzzification assigns degree of memberships. That means if for a particular point where the frequency drops from 0. Suppose it is 0.2 hertz to 0.7 hertz or 0.10, so it will categorically assigns all the value of 0.7, 0.10, that is for the moderate value. It will assign the 0.2 as the lower value. So it doesn't happen. It doesn't mean that suppose for sample 1, I have sample 1, the frequency lies from 0.3 to 0.9. For sample 2, it lies from 0.5 to 0.9. So 0.5 that will take as the moderate one, but 0.3 it will take as the lower one. So that means depending upon the value, depending upon the value we have input, it will assign them as the membership function. For that membership function, it is high or low. Then this allows the smooth handling of the uncertainty and noise data, as we have discussed. So the rule evaluation, for the rule, the system applies the if-then rule. If this frequency drop is high, then what should be, then the location should be nearer, or location should be higher, or the severity must be higher. The aggregation, that is the combining result from the all active rules. So we have to provide the rules for writing the rules for that if then rule. So number of rules, it will combine all those number of rules to produce a single entity. So every rule is producing an active result. Suppose I am writing 1000 rules. So 1000 rule will produce 1000 active results. It will combine those all 1000 active rules to produce one single result. So it will be more crisp or more profound. So that's why it will give a robust answer for the crack detection. Then defuzzification, that will generate the crisp crack decision output. So based on that all input data, the FIS simulation will provide a robust technique that will capable of detecting the cracks inside the structure or on the surface of the structure. So that means if the fuzzified thing or the fuzzified inputs provide 1000 rules for 1000 results, those 1000 results on defuzzification will give one crisp output about the location and the depth of the crack on the surface of the crack or inside the structural element. So that's why the fuzzy inference engine excels in handling the ambiguity in crack detection, processing uncertain inputs through human-like reasoning to produce reliable structural assessments. So in presenting those values in the most noisy ways or most ambiguous ways, the fuzzy inference system or fuzzy inference, that simulation will enable us to find a more crisp output, and that need to be verified through the experimental analysis. So these are the fuzzy membership functions. Here is the triangular membership function. We can say that first natural frequency, second natural frequency, third natural frequency as the input elements, and after defuzzification, we got the value crack location and crack depth. CL for crack location, CD for crack depth. FNF that implies first natural frequency, SNF second natural frequency, TNF third natural frequency. So different membership functions are there. So this is for the first as triangular membership function. This is Gaussian membership function. It will give a more robust value than the triangular membership function. So whatever the membership function we are choosing, through that membership function, we got the output result. Now this is the hybrid membership function. In hybrid membership function, both triangular membership function and Gaussian membership function are used. So hybridized. So for that same first natural frequency, whatever the output through triangular membership function, that through hybrid membership function, it will be more crisp. That means if I'm comparing these three figures for triangular membership function, Gaussian membership function, hybrid membership function, hybrid will provide more closest value to the reality. Or we can say that more crisp value for that fuzzy analysis. Whatever the triangular membership function gives the value, Gaussian membership function will give more crisp value. And combining these two will get more closer value to the reality. So if the surface crack is closer to the end support, that means through hybrid membership function, we can find a value that is more closer to the end reactions. So how the translating the numbers into linguistic terms. Linguistic terms are very important. So we are the linguistic terms can be classified to low, medium, high. So how this can be measured? For small cracks, 0 to 2 mm width, it is low severity. For medium cracks, 1.5 to 4 mm width, we can term as the moderate concern or medium concern. For large cracks, with 3 mm plus, it is high priority. So that means if through fuzzy logic we found that the depth of or width of the crack is 0 to 2 mm, so the functionality of the structure is intact. It needs a little attention about that region only. For medium cracks, maybe a small portion of that pad can be rehabilitated or can be reformed. With large cracks, we can assure that the structure cannot use about its full potential and it need to be replaced. So these are the fuzzy membership function for vibration analysis. So this is the triangular membership function. It is generated through MATLAB platform. So there is a window in MATLAB to analyze the fuzzy logic application or to employ the fuzzy logic application. Through that MATLAB platform, it has been generated. So this is triangular. We have using the membership function in two ways, that is Mamdani FIS and Sugeno FIS. So Sugeno I have not used yet. So Mamdani FIS I have we use that Mamdani FIS for all the research. So Mamdani for triangular, this is Mamdani FIS for trapezoidal, this is for Gaussian, this is for hybrid. So here we can clearly see, it is clearly visible that we have input the four natural frequency: first natural frequency, second natural frequency, third natural frequency, and fourth natural frequency. All the fourth natural frequencies are provided as the CRIS input to all the Mamdani FIS, be it triangular, trapezoidal, or Gaussian or hybrid. All the natural frequencies are provided the CRIS inputs. Through that FIS simulation that we have discussed earlier, after the defuzzification, it governs the result as crack location and crack depth. So whatever the crack location we got for the triangular, it will better crisp for trapezoidal, then Gaussian. Then after all, after the hybridization, we got the more crisp value or more closer value that resembles the numerical values or the experimental values. In the same way, the buckling analysis also done. the 4 modes of buckling, that is buckling load 1, buckling load 2, buckling load 3, and buckling load 4 through that Mamdani analysis, triangular, trapezoidal, Gaussian, and hybrid got the value. So this is the linguistic variable for vibration. So the linguistic term that is in the first column, it is VBS, that means very, very small. So that is linguistic variables are first natural frequency, second natural frequency, third natural frequency, then fourth natural frequency. So it indicates that the VBS means very, very small value of first, second, third, and fourth mode of natural frequencies. Then linguistic variable for VS, that is for the very small value for the first, second, third, and fourth natural frequencies. Then S equal to small value of first, second, third, fourth natural frequency. So in this way, we are going to calculate or going to evaluate the natural frequencies, the input value as natural frequencies, and what are the output values. So from very, very small to very, very low. So we got the input values. So what are the output values? That is VBC, very, very close value of crack location and crack depth. Suppose we are calculating for the cantilever beam where one end is fixed, another end is free. So if the value of the crack position is nearer to the support, we got the value as the frequency drop is quite high. So that means through that linguistic variable, if you read that, that is VVC, that means very, very close value of crack location. So very, very close value of crack location towards its end support, where the fixed end is there. At the free end, it is generating the same value as of intact beam. If you are going for the fixed beam, in fixed beam at the mid support, the frequency drop is quite high. It will give the very, very close value for the crack location at the mid span. So in that way, this linguistic variable work. So for the vibration, it has been written for input values and output values. For input values, that is VBS, VBS, S, M, L, all the values. L equal to large value of first, second, third, fourth natural frequencies. Then after that, CLCD that represents the crack location and crack depth. Then very, very close, then very close, then close value. A equal to IWA value of the crack location. VA very IWA, VBA very, very IWA. Those linguistic terms can be changed. I have taken this term as that is more suitable for the human thinking. So the linguistic variables can be changed. Somebody can take very, very small or very, very low BBL. That can easily write that the very, very low values of the first, second, third, and fourth natural frequency. VBM somebody can write very, very minimum value, very, very maximum value. So provide a pattern which can be very general to the human thinking. The same way for buckling forces is also written. So VBS, that is very, very small value for first, second, third, and fourth mode of buckling. Very small value of first, second, third, and fourth mode of buckling loads. Then VL equal to very large. So similarly, we are getting the output values are CL and CD, that is crack location and crack depth. Actually, the crack detection using buckling variables has not been published yet. We are the first authors to publish those values. We have been working on it since a very long time, and I have recently published 3 to 4 papers regarding that linguistic variable regarding buckling analysis and crack detection using the buckling responses. You can find many results regarding the crack detection using frequency responses, but there was no literature or no study that presents the crack detection using the buckling responses. So the buckling responses are clearly structured here, and all the structured values governs the crisp outputs. So the rule-based reasoning enables the intelligent crack assessment by combining multiple features. So rule 1, that is the high severity detection. If that explains if the crack width is large and texture intensity is high, then the crack severity is high. So like this, we can write the rule. The rule 2, the low presence confidence, that is if the crack length is small and edge clarity is low, then the crack presence is low. Rule 3, that is the moderate assessment. If the crack width is medium and the depth is moderate, then monitoring is recommended. So in that way, where the fuzzy rule based, the decision logic is works. The decision logic is work. So these rules work together for handle uncertainty and noise in real-world crack detection scenarios, providing robust assessment even with incomplete or ambiguous data. So whatever the data we have, very raw data, even it is incomplete, even if it is noisy, even if it is not robust, then also fuzzy can effectively analyze it and produce the output data. So these are the rules, hybrid rules using frequency data. So clearly you can see that if natural frequency is VBS, that is very, very high, that is highlighted portion. So rule number 1, if it is written there, if you can see that if natural frequency is 1 is high, very, very high, and natural frequency 2 is very, very high, and natural frequency 3 is very, very high, and natural frequency 4 is very, very high, then crack location is very, very near, crack depth is very, very near. That is rule 1. Again, if you go for the rule 2, number 2, it is written if natural frequency is very, very high, natural frequency 2 is very, very high, natural frequency 3 is very, very high, and natural frequency 4 is very, very high, then the crack location is very, very near and crack depth is very near. It has been changed there. So all the permutation combinations we have to apply there. So the first rule, crack location is very, very near, crack depth is also very, very near. But here, crack location is very, very near, crack depth is very near, not very, very near. If you go for the 9th rule, we can say that if natural frequency 1 is very, very high, natural frequency 2 is very high, and natural frequency 3 is very, very high, and natural frequency 4 is very high, the crack location is very, very near, and the crack depth is very far. So in that way, we can write the rules there. For first rule, it is selected. So in MATLAB user interface, it will show you how to write the rules and which method you have to apply, AND method or method. It is there the connection in the bottom side of the left bottom side corner written that selected as it is AND form. So for NF1, it is written that if NF1 is very, very high and NF2 is very, very high, NF3 is very, very high, and NF4 is very, very high, CL is very, very near. You can clearly see that selected portions there, VBH, 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 then CL at the top, it is VBN, it is written there. So in that way, we are going to add the rules. Here we are going to write the rules. Here only I have written 13 rules. Actually, we have written 12,000 rules. More than 12,000 rules. You can see it on the buckling data. So buckling data, it is even more. So here I have shown you for the 1116, but actually it is more than 13,000. It was more than 13,000. So that we can get the answer, more precise answer or more robust answer, and it is more close to the whatever value we got from our experimental analysis. Here also same way, we are going to we have provided the data as low. You can see that if buckling load 1 is low, buckling load 2 is low, buckling load 3 is very low, buckling load 4 is low, then crack location is very, very near, crack depth is very. So like that only, you have to provide all the data. That means if first rule I have written that every first position there, I can write that very, very low, very, very low, very, very low, very, very low. Then crack location is very, very near, crack depth is very, very. In the second rule, we can write buckling load 1 is very, very low, buckling 2 is very, very low, buckling 3 is very, very low, buckling 4 is very, very low, then crack location is very, very near, crack depth is very near. Then the same thing we can produce the crack depth is very near, far, very, very far, not found, none. Then again move to the second thing, that is if buckling load is very, very low, buckling 2 also very, very low, buckling 3, buckling load 4 also very, very low, then crack location is very near and crack depth is very, very near. So we are changing the crack location values, that is very, very near to very near, far, very far, very far, like this. Again move to the second assumption, that is very low. So if buckling load is very low, buckling load 2 is very, very low, buckling load 3 is very, very low, buckling load 4 is very, very low, then crack location is very, very near, very, very low. In that way, you are going to write the rules. It will take a whole lot of time. Or manually, you have to write those values. That means you have to select all those values there and very precisely, very meticulously, you have to choose the rule, so that at the end output, more the number of rule, more will be the crisp output. The surface plot will be generated more crispier and it is more robust. So this is the rule view for the frequency, where you can find out for triangular membership function, trapezoidal membership function, Gaussian membership function, and hybrid membership function, where your yellow lines that represents how much each input belongs to the fuzzy set, that is membership level. So that is actually your input activation or fuzzification level. At fuzzification level, how much each inputs belong to the fuzzy set. So if we are calculating, if here use NF1, NF2, NF3, NF4, we can see that at NF2, there is more number of yellow lines. At NF3 also more number of yellow lines. That means how much each input belongs to the fuzzy set. Your number of rules will decide how much it belongs to the fuzzy. If fuzzy membership function is a triangular, the number of rules for that particular value, for that particular frequency will define how much crispier it is. If the input is much more crispier, output will definitely be crispier. Similarly, your blue line shows how strongly each rule contribute to the output. That is your output activation or rule firing strength. Your input rules are yellow, your output rules are in blue. So similar observation you can find from the buckling analysis, where you can find here, if I have told you that we have provided more than 13,000 rules. Now you can see that for the trapezoidal section, buckling load 1, it comprises of all yellow lines. Actually buckling, the mode is in experimental, the mode is 1, but in numerical you can find 10 modes of buckling. So here it is clearly understood that as fast mode itself you got all the values, and also your blue line represents how strongly each rule contributes to the output, that is output activation. That is also for the mode 1. So crack location and crack depth can be easily understood from the trapezoidal membership itself. As compared to the triangular or Gaussian, trapezoidal gives more crispier values. Sometimes Gaussian will also provide the more crispier values. Now combining those triangular, trapezoidal and Gaussian is providing a more robust value through the form of hybrid membership function. Now this is the developed FIS, which is validated against generator. They have used the neural network, and we have used the fuzzy logic. So we compared the relative crack depth and relative crack location through neural network and through present hybrid Mamdani fuzzy inference system. So you got very little deviation that for RCD, it is, we can see that for the fast natural frequency, relative natural frequency, that is RCD got 0.39%, RCL also 0.39%. So within 1% we got all those values. That means we have developed a very robust value that can produce the same result as of neural network. So this is the fuzzy inference process for vibration. So we have provided the value. You can see in the red highlights that for the first frame, it is first natural frequency. For the second frame, it has taken the second natural frequency. For third frame, it is third natural frequency. For fourth frame, it is fourth natural frequency. After the defuzzification, the output given as the crack location, it is highlighted in the last two figures, that crack location and crack depth. So the crispier inputs that perform through the fuzzy logic application, the outputs have been the crack location and crack depth. So this is the fuzzy inference process for buckling. So here we have used the hybrid membership function. We can clearly see that for buckling load 1, 2, 3, 4, we have used the triangular membership function. We have used the Gaussian membership function. We have used the trapezoidal membership function. Combining all those membership functions, your output is also as a combination of triangular, Gaussian, and trapezoidal. That will give the crack location and crack depth. So these are the surface plots that are generated for the MATLAB. So comparing the different frequencies, we can see that is NF1, natural frequency 1 against natural frequency 4. That is for crack location, natural frequency 1 for natural frequency 2, natural frequency 1 with natural frequency 3. And for crack depth also same thing. We can also vary from natural frequency 3 against natural frequency 4, natural frequency 2 against natural frequency 3 or natural frequency 4. Here for the representation only, all the variations against natural frequency 1 is presented. So these are the quiver plots. So what is the basic quiver plot means? That is the direction and magnitude of fuzzy inferred decision gradients. It provides the direction and magnitude of the fuzzy inferred decision gradients. So we can see it here, the quiver plots for the stable region. It is there for direction change. We can see from the three zones that has been highlighted, the high sensitive region, direction change, transition zone, or stable region. From beginning 345 to 350, it is natural frequency 345 to 350. We can say that this is a stable region. After 350 Hertz, the direction change, transition zones are there. So that means the severity cracks have been experienced. And after 360 Hertz, we can experience the distorted figure that enables the reader to identify, yes, there is a severity of the crack. That means the depth of the crack is increasing or the location of the crack is shifting. So similarly, so it is understood for natural frequency 1 against natural frequency 2. So we can generate the quiver plots against natural frequency 1 to natural frequency 3, natural frequency 1 to natural frequency 4 also, and natural frequency 2 to 3, natural frequency 3 to 4, like that only. The number of permutation combinations can be applied and number of figures can be presented for the quiver plots. And here you can see a lot more crispier outputs, a lot more crispier surface plots for the buckling analysis, where you can see that this is the stable behavior zone, this is the high sensitivity zone, this is the transition region, this is the severe crack influence, this is the parameter coupling effect, and here it is the moderate damage zone. So here you can see that buckling load 2 to buckling load 4, buckling load 2 to buckling load 3, then buckling load 3 to buckling load 4. You can find all such combination there. For all such combinations, the number of rules can generate such kind of figure. So these are the surface buckling plots also. That is buckling load 1, 2, 1, 3, 1, 4, then 3, 4, 2, 4, then 2, 3. That is for the crack location. This is for the crack depth. And here we have found the HSB mesh plots. So HSB color map that is actually used to encode the increasing crack severity. This is from blue, green, yellow to red. So the rapid change of color that indicates the highly sensitive regions, where the small changes in the beam geometry can be strongly felt. Small changes, any small kind of changes in the beam can be strongly felt, strongly realized. So we're explaining that. So from this region, we can say that this is the highly crack level zone. That means the red portion is quite high. So wherever is the red portion is quite high, it can be realized that the crack severity is more. Then this is for the moderate transition zone, where you can see the blue and blue and green colors are more visible, or blue colors are more eminent. Here we can say the healthy low damage region, where you can find the faded colors of green and faded colors of red, where that means the crack propagation is not high. The crack propagation is very low. Here you can see that the sharp nonlinear rule switch boundaries. Here the strong parameter interaction areas, and here you can find the stable low sensitivity zones. So in this way, the HSV mesh plots can define the sharp color edges or boundaries that represent the rule switching behavior that demonstrates the fuzzy if-then rule. If the crack location zone correspond to the geometrical configuration associated with the stiffness degradation. So from that fuzzy logic, we can clearly feel how the stiffness is degraded, and through that stiffness, how the structure is affected with the implication of cracks. So in this way, we can find what is the position of the crack and what is the depth of the crack. That means the crack severity towards its position and towards its depth that can be realized. So this is the HSP mesh plots for the crack depth. This is for the crack location. This is for the crack depth. In the similar way, we can find the severity of the, or that sensitivity of the crack. This is the validation of the developed model with the experimental value, and the percentage of error we can find for the triangular membership function. So using the vibration data, the percentage of error is 20%. For trapezoidal, it is 5.8%. And for Gaussian, it is 4.07%. And for hybrid, it is 2.6%. That means using the hybrid membership function effectively produces the close resemblance result with the experimental value. Now again, the buckling loads are also when provided as the input parameters. It is also validated against the experimental value. For a triangular, it is 18.13. For trapezoidal, it is 7.6. There is a sharp decrease. For Gaussian, it is 2.67. Gaussian value, it's a Gaussian membership function itself governs very crisp results. And for hybrid, it is 0.9. It is more close to the, or most close to the experimental value. So the developed model we have used through experimental validation, it has been attained the robustness, or we can say that the precision is quite high. So for a particular set of frequency set, we have against the fuzzy logic, we found the we got the value for the crack location. For first set, it is almost equal. For second, third, fourth, fifth, up to ninth set, you can see that there is no major deviation from the numerical or from the experimental results. Whatever the value I get for the physiologic from the physiologic, you got exactly the same value from the experimental results. This is for the crack location and this is for the crack depth. Here also we are getting the same value as of the experimental value. So the physiologic value effectively produces the Mamdani fuzzy inference system, the Mamdani FIS that effectively produces the same result as of the experimental results. So in both way, it has been validated against the published literature and validated against a robust experimental analysis. So what are the advantages of fuzzy logic in crack detection? That is robust to noise. As I said, that this handles noisy and incomplete image data effectively. Be it image data, be it vibration data, be it structural data, every data it can be, it handles effectively. This is real-time monitoring, enables the automated continuous structural health monitoring without human intervention, reducing the inspection cost and improving the response time. You can, one can monitor the structure by seeing in his office, in his room, through a display system, through a laptop, using the fuzzy logic, by gathering the data and inputting those data. If you got the value as the severity of the location, severity of the crack depth, it can be easily monitored. And most effectively, it is the human-like reasoning, mimics the expert inspector reasoning for the ambiguous crack patterns. So whatever be the crack pattern, it can detect those cracks or detect that location at that point or most close to that point. Reduced expert dependence. So if one can identify the cracks by sitting in his room, in his office, so it also reduces the expert dependence. So one case study from University of Calcutta, it shows that the successful identification rate is decision detection accuracy is 90%, greater than 90%. 3x faster inspection compared to the manual methods, and 40% cost reduction or lower maintenance expenses. So that result, the enhanced safety protocols, predictive maintenance capabilities, and significant operational and efficiency across the bridge infrastructure network. So the concluding remarks that fuzzy logic empowers smarter crack detection. It acts like a human-like intelligence. It's a reliable assessment, and also it is a next-gen technology. A lot of things to be explored, need to be explored through fuzzy logic, and especially in laminated composite, it is mostly an untouched part. So different types of data can be integrated. Like I have integrated the buckling data. So both vibration, the combination of vibration and buckling data also can be integrated. So different methods are also there. I have used only the Mamdani FIS. There is also a Sugeno FIS where data need to be inputted, or data need to be input, and the output is generated automatically. Here we have to produce the output data by defuzzification. It will defuzzify the data immediately and it will produce automatically. That is the Sugeno technique, and that is the more efficient one. Then integrating the fuzzy logic with genetic algorithm, integrating fuzzy logic with the artificial neural networks. Already some people are working on it, that is ANFIS. And integrating fuzzy logic with other AI techniques also, that is deep learning, machine learning. So integrating those data will govern a more robust method or a more robust technology towards the structural health monitoring. In today's days, structural health monitoring carries a lot of importance, and when it comes to the laminated composite, certainly it is the most important. So fuzzy logic transport the crack detection from subjective manual inspection to the objective, scalable and intelligent automated assessment, paving the way for safe, more resilient infrastructure. So these are some publications we have. I refer this publication for this presentation. Any questions?
So participants are requested to ask any questions or doubts on the topic presented today by our expert. Participants are requested.
Priyadarshi, this is Bipin sir.
Sir, namaskar.
Namaskar. Let me share few words.
Sir,
I am extremely glad by attending your presentation. I am proud of you. My blessings
you.
are always with you. You go
Thank you, sir.
ahead by gaining more and more knowledge. Thank you.
Thank you, sir. Thank you, sir. Your words are most meaningful to me. Most meaningful.
Any other question? Any question? Thank you, Bipin sir, for your encouraging words.
I am so glad I don't have any question to my student.
Sir.
Participants,
Sir,
participants.
I have a question. Sir, I have a question, sir.
Yes, ma'am.
Sir, in one of the slide, sir, you had mentioned about texture intensity is high. Then it shows a parameter. Sir, what is exactly texture intensity, sir?
It shows how qualitatively the inputs can be presented. The interpretability of the data, how qualitatively it can be inputted. So if the data can be interpreted in such a way that, so I have given 4 input data: natural frequency 1, natural frequency 2, natural frequency 3, natural frequency 4. If I'm going to provide 10 data, so whatever the surface plot we got, let me show you that slide. So here, the surface plot we get here, you can see that the texture of that surface plot is quite crisp. So it will be more crispy, it will be more sharp, and the mesh size you are getting there. So for here, like you are getting the triangular values. So you will get more crispier values that will be more visible, and the color patterns are also more visible. That's why I have given HSB values for the buckling load analysis and quiver plots for the vibration analysis. The texture of that surface plot will be more crispy. That is the texture value. Am I clear, ma'am?
Thank you, sir. Thank you.
Any question? Any question from our participants? So I think whatever delivered by our expert, it is clearly understood by all the participants. That's why there is no question from any our participant side. No more question. So thank you, sir.
Thank you, sir.
Thank you, sir, for your nice presentation. And I am also very happy to see you in this platform. And continuously, these two sessions are very interesting and very informative. And I request the participants, if they have done their MTech and want to register for PhD, so I'll definitely recommend, please register under our expert sir in Shiksha Anusandhan University, and I hope you will come out with a better knowledge and analytical modelings, simulations, etc. Also, I request you, sir, to take some students from this FDP program.
Definitely,
And
sir.
you,
Actually, the
uh,
last slide I presented some the publications. Those are from my PhD students, sir.
no,
They are doing this.
nice work, nice work. Because when I had joined my PhD, actually I joined under Ajoy Naik sir, who is master in this in BSSCT Burla. He's
Yes, sir.
master in this, but unfortunately he passed away. So I have no other option and do the experimental as well as my work is also this machine learning, based on machine learning. Anyhow, your work is very nice. Your presentation is very nice. It is very informative, and thank you so much being a part of this program. And
Sir, I need to thank Ansuman and Mosumi also because
I, I am also thankful to them because they suggested that our teacher is very interested to share his view in this FDP program. I am also thankful to Mosumi madam and Ansuman sir. And
sir, both Mosumi and Ansuman are my students, and
I,
I
I
really
know, I
appreciate their
know,
efforts.
I know that both are your students, and they are also very good students. They are very good
Sir,
teachers
definitely.
now also. They are very good teachers now also. Uh, both are doing excellent jobs. So many best wishes to them, and also uh, many wishes to you also. Go ahead,
Thank you,
and
sir.
your presentation your presentation is extremely informative. So thank you so much, sir, for being a part of this program. And now I request you, with your due permission, we want to close the presentation for this session today.
Yes, sir.
Thank you, sir.
Thank you, Mosumi.
Thank you, sir.
Right, sir. Namaste.
ନମସ୍କାର ନମସ୍କାର
Okay, good night, sir.
ଚେହେରା ଭୁଲି ଯାଇଥିଲି ପରେ ମନେ ପଡିଲା
Thank you, sir.
Okay, good
Thank
night,
you,
sir.
sir.
ଏମିତି ଜିନିଷ ତମେ ସବୁ ଆରେଞ୍ଜ କରୁଛ ନା ଇଟ୍ସ ଏ ଗୁଡ୍ ଥିଙ୍ଗ ମାନେ
And I want to say something.
ସାର୍
All the credit goes to Mosumi.
yes sir definitely
She is very dedicatedly doing all these works. Very dedicatedly.
yes sir yes
Okay.
sir
Good
yes
night,
sir.
sir. Thank you
Good night.
so much.
Good night to all the participants.
Good night, sir.